Suppose that we do want to do something to change the way we're creating intervals or change the way we're interpreting our hypothesis tests to take into account the fact that we may have done multiple tests. What should our goal be? What should the goal of such a method be? There are two sets of goals. There's two ways people have thought about this problem, at least two. One is historical, so some of the older methods are based on one particular goal you might have when dealing with this problem, and then the other goal is a little bit more modern and more adapted to current research problems. We'll first talk about the older goal and the more established methods for dealing with the multiple comparison problem, and then we'll talk about the newer goal you could have and how methods have been created to meet that goal. So here's the older goal: to deal with the family-wise confidence level, or the family-wise error rate. So what does family-wise mean? The family-wise confidence level is the probability that every single one of a set of intervals covers its true value. So you have a family of intervals, all the intervals you're planning to create for a particular project, and instead of saying, well, this is a 95% confidence interval and this other one is also a 95% confidence interval, and so each one has a 95% probability of covering its true value, instead we're going to talk about the probability that all of the intervals are successful in covering their true values, and we're going to try to get that confidence level to be 95%. In parallel, we can talk about this family-wise goal for hypothesis tests. Instead of saying each hypothesis test that I run uses a 0.05 cutoff and therefore has a 5% chance of falsely rejecting the null hypothesis, instead we can think about the family-wise error rate. If I run a hypothesis test for a family of tests a whole bunch of different times, what is the probability that at least one null hypothesis is falsely rejected? And we can make sure that that rate is no bigger than 0.05.